All right, so welcome to the last video here in Unit 2 Dynamics. And I'm calling this the water line because I often refer to Units 1 and 2 in AP Physics 1 as duck on a pond physics, right? So if you think about a duck on a pond, right, Unit 1 we describe, right? Oh, that's so pretty that the duck is floating on the pond, right? Look how graceful it moves around, right? We're not diving underneath the water to see what is actually happening. So I call it the water line. So anything above the water line is Unit 1, right? Those descriptors, it's kinematics, right? Describing motion. Now we're going to go underneath the water with our Unit 2 and our dynamics, right? So now we're going to put it all together, right? Now the water line, you can think of it as this. There's one concept that we talked about in each unit, right? That showed up, and that was acceleration. The acceleration in Unit 1 was defined as change in velocity with respect to time. And then in Unit 2, we talked about how it's directly proportional to force and inversely proportional to mass. Okay? So you may have to do a problem where you start above the water and then go down, or you start in the water and work your way out. Okay? But what you have to do is at some point in time, you have to find the acceleration. Okay? So, like I mentioned, the first two units, I really talk about like ducks floating on a pond, and that's how you can drill that into your head. That's what it is. Okay, above the water is kinematics, so that's Unit 1. Under the water is dynamics, right, or how it's going to move, right, and that's what we're doing in this set of videos. The water line, or the connecting piece between them, is acceleration. So when you do problem solving, the process will be solving for acceleration using either kinematics or dynamics, and then plugging that acceleration into the other unit's equations to find the rest of the information. So if you remember from the Unit 1 playlist, those cake equations, you may have to find acceleration and use it in F equals ma, or you go the other way, right? So find acceleration equals F equals ma, and then go into the cake equations, all right? So let's look at an example. So a motorcyclist coasting with the engine off at a steady speed of 20 meters per second enters a sandy stretch where the coefficient of friction is 0.7. Will the cyclist emerge from a sandy stretch without having to start the engine if the sand lasts for 15 meters? If so, what will be their speed upon merging? So here we go, right? And so we're going to do Unit 2, Unit 1. So Unit 2, I need to find the acceleration using Unit 2. So if I'm coasting, remember the only thing acting on a coasting object will be friction, right? And so if I do my T chart, right, there's my draw step. Now we do our summing step, all right? I'm going to sum in the y direction because there is friction involved. I need the normal force, okay, which is very standard. We've done this numerous times in this playlist. Now in the x direction, I'm going to do the only force I have acting is friction, and that's going to equal acceleration. There's my connecting piece because I need that for over into Unit 1. And so I'm going to have negative mu times Fn, which is equal to m times a. But we found Fn to be mu g, and I would recommend doing all of your algebra and solving, because then maybe the equation becomes easier. Yeah, we can plug in our numbers here and talk about like, oh, this and that. But one thing, notice that this problem does not give us mass. So we do have to go through and solve everything out to get a relationship with the numbers that we have. And really, for dynamics, the only number we have is the coefficient of friction. And so my acceleration is going to be negative mu g. Right? And so now I'm going to find my acceleration, negative 0.7 times 9.81. And my acceleration is going to be negative 6.87 meters per second squared. Why negative? Because it's coasting, right? And friction, if the motorcyclist is heading to the left here, remember friction is acting to the right. Okay? And so motion, friction. So they work against each other, so I have a negative acceleration. Now, so I have my acceleration, so I'm at the water line. So I'm coming out of the water, right? So underneath the water is my dynamics, and I'm going up through the water with my acceleration at the water line. Now I'm going to go and do my descriptors, or I'm going to describe what is happening. So I need to use my cake equation. So I've got an initial speed, okay? I have a distance, and I have the acceleration. So notice I don't have time, so there's one equation that does not have time in it, and it's that v squared equals VO squared plus 2a delta x, okay? So what I'm doing here with this equation is I'm going to try to determine how fast they are moving, right? I'm actually going to answer this question, right, to answer, will they make it, right? So if they have a velocity at the end of 15 meters, then yes, they'll emerge out of this sandy stretch of their travel. So I'm going to say v squared equals VO squared, so that's 20 squared, plus 2 times negative 0. It's not 0 point, it's 6.87, right? So negative 6.87 times 15. Okay, so again, with this equation, be careful. So we got v squared equals 193.93 meters squared per second squared. Again, I got to do one extra step. I have to take the square root of both sides to get my answer. And I find that we're traveling just around 13.9 meters per second. So do they emerge out of the sandy stretch? Yes. How fast are they moving? 13.9 meters per second. Okay. So that's the end of Unit 2 with dynamics. So remember, just topics. We talked about Newton's laws. We talked about, and then the rest of the unit really focused on the applications of the laws. Okay. So you are now ready to take this portion of the AP Physics 2 or AP Physics 1 exam. But remember, this is a big chunk of the exam itself. So make sure that you do understand these. And on free response questions, again, they'll connect it to Unit 1, they'll connect it to Unit 4, and they'll just put all this stuff together into one giant free response question. So be on the lookout for that. All right. So moving forward, we'll look at Unit 3. Our next unit is Unit 3, which is talking about gravity and circular motion.